Here we have two linear inequalities, and we're being asked which pair of points goes with this set. Now, in this situation, you want to see this graphically first. And if that doesn't work, then you can resort to plugging in the points. So let's just imagine an XY axis. And let's imagine the line that goes along with this inequality, because this could be y equals 3x plus 1 if it were just a line. And so that's in a y equals mx plus b format. And we know that the slope is 3, the y-intercept is 1. So let's plot that y-intercept of 1 and the slope being 3. That means it's rising 3 and going over 1, because 3 is really 3 over 1. So up 3 over 1. And we're going to go ahead and connect that with a line. Let's put a line on here. Get it going in the right direction. And so that's our line. Now, what you should know about it, graphing inequalities, is that if you have less than or greater than, it's a dashed line. Less than or equal to, greater than or equal to, it's a solid line. So this should be a solid line. Now, it's less than, which means we're thinking of values that are less than this. In other words, lower than this. So less than would mean to shade below, and greater than would mean to shade above. So let's do that. Let's shade below this line. And that's our shaded region right there for the first inequality. Now let's look at the other one. The other one needs a little work to get into y equals mx plus b form. Here, we can start by taking away x from both sides. So negative y greater than negative x plus 1. Now, we would be dividing by negative 1. And you want to be careful with that, because when you multiply or divide an inequality by a negative, you reverse the inequality symbol. So this would be y is less than positive x minus 1. So just to show that we flipped the inequality around because we divided by a negative. So we've got y is less than x minus 1. Now that is in y equals mx plus b format if you imagine that there were an equal sign there. So let's imagine we had y equals x minus 1. The slope would be the invisible 1 in front of the x, and the y-intercept is the negative 1. So let's go to a y-intercept of negative 1, and let's have a slope of 1, which is the same as 1 over 1. So rise 1 over 1, rise 1 over 1. And our line looks like that. Now, we said that if it were greater than as opposed to greater than or equal to, it's going to have a dashed line. So when we put our line there, we're going to try to make it look like a dashed line. So let's go ahead and do that. Let's get a line that goes through those 3 points. And let's make it a dashed line. So we'll just put little sort of white dots there to signify that it's being dashed. That's just the idea that the line is dashed. Kind of the best I can do in this situation. Okay, so we've got a solid line and a dashed line. Now we are less than that, so we're shading below. So let's go ahead and show what it looks like to shade below that. And you can see from the way the colors are mixing where it is that we shaded both times. Now, if you're watching this and you're thinking to yourself, man, that takes a long time. How can I do that? I think it's only taking a long time because it's hard to do this on a computer, but on a piece of paper, I can do a mock-up of this in 2 seconds. Of course, a little more. But which of these points looks like it goes here? So -2, -1, clearly not. -1, positive 3, clearly not. 1, positive 5, clearly not. And 2, negative 1 is clearly in that double shaded region, and that is going to be our answer.